We are, as it says on the board, we're looking at finding the values of the trig functions for acute angles of a right triangle, or of right triangles. That's what we're doing today. So, what do you guys know about trig functions? Alright, I hate that. Sine, cosine, and tangent. What do you know about sine?
It uses opposite.
Opposite over hypotenuse. What do you know about cosine?
Uses adjacent over hypotenuse.
Adjacent over hypotenuse, and tangent.
Opposite over adjacent.
Opposite over adjacent. Now, those are three. There are actually three more trig functions.
Oh, no.
Not inverses, reciprocals. There are reciprocals of those three trig functions. And those are, and I'll write on the board here in a second, I'm just talking to you right now. Those are cosecant, secant, and cotangent. The other three are those, and they are related to the first three because those three are the reciprocals of the first three. Okay? So that's what's going on there. But, what do you think trig, or right triangle trig is about?
Angles.
Not necessarily angles.
Side lengths.
Say it again.
Side lengths.
Alright, and combine those two. It has to do with how angles and sides are related to each other. That's what's going on with trig. So that's what we're going to be working on today. Alright, but first we want to talk about the 6 trig functions, and you need to write them the way I write them on the board. Okay? So I have sine, and we'll talk about what this is here in a second. And then we have cosecant, we have secant, and we have cotangent. Okay, now what did you say, Hunter? That is theta. And what does theta represent?
It's a
Cotangent. Cosecant. CSC.
No, the last one on the first set.
Tangent.
Tangent.
My T's messed up.
Yeah.
Well,
Why you gotta do this handwriting
That was a T.
You're going to talk? You're going to talk about somebody's handwriting?
It just looked like the funny little Z with the line.
Uh-huh. C-O-T. So I got sine, cosine, tangent, cosecant, secant, and cotangent. We write it this way because the three on the right are the reciprocals of the three on the left. Okay, so we need to know that sine and cosecant are reciprocals of each other. We need to know that cosine and secant are reciprocals of each other. What's an easy way to notice that these two have to go together and these two have to go together? What do you notice?
like, I don't know how I
one is a co middle, one is top.
I know.
The way I do it is that a S never goes with an S, and a C never goes with a C. An S always goes with a C. They always go together. Never a C and a C or an S and an S. And it should be easy to identify that tangent and cotangent have to go together. Okay? Say it again. Because their names, tangent and cotangent, they're the same name. So, now, what did we say sine was?
Opposite over hypotenuse.
Opposite over hypotenuse. What was cosine? Adjacent over hypotenuse. Now, those two are the key to finding all of your 6 trig functions, because if you know what those two are, then the other 4 fall into place very easily. If you know sine and cosine, here's how you get tangent. Tangent is the top of sine over the top of cosine, so that makes it opposite over adjacent. Okay, so tangent is always whatever the top of sine is over what the top of cosine is. And then what did we say the 3 on the right were? Reciprocal. So that means I've got to have hypotenuse over opposite. I've got to have hypotenuse over adjacent. And I've got to have adjacent over opposite. So, those are my 6 trig functions. And what do you notice trig functions are? What are trig functions? What's the most basic definition of a trig function? What does it
Functions
represent?
that are significantly larger.
What's another word for fraction? It starts with an R. Ratio.
Ratio.
All the trig function is a ratio of two sides of the right triangle. That's all a trig function is. It represents a ratio. That's something we have to get into our head, because we'll get to where we're trying to evaluate a trig function and we'll forget that a trig function, all it is the ratio of two sides of a triangle. Okay, so we need to keep that in mind. So let's see what everything looks like on a triangle. Okay, and we said we're dealing with a right triangle. What does it mean for it to be a right triangle? It has 90 degrees. So what are the other two? What do the other two angles have to be? They have to be acute. What does acute mean again?
Less than 90.
Less than 90. Okay, and all three angles have to add up to 180. So, what's the easiest side to identify in a triangle? The hypotenuse. How do we identify the hypotenuse?
Opposite of 90.
It is across from the 90-degree angle, or it is also which side? The largest side. So that means this side is hypotenuse. So then I need to identify what my other two sides are. What are my other two sides? Adjacent and opposite. So which side is the vertical side? Opposite is the vertical. Okay, how do we know, Kaylee, how do you know that that's the opposite side?
Because it's opposite of the angle that you're trying to.
Because it's across from the angle we're dealing with. Good. Which means the other side has to be. Now, what's something that the opposite side does not do that the other two sides do?
It's not next to the angle.
It doesn't connect to the angle. Okay. The hypotenuse side and the adjacent side connects to the angle we're dealing with. Notice that the opposite side does not touch the angle we're dealing with. So that's an easy way to make sure if you're confused about which side's opposite and which side's adjacent, the opposite side does not touch the angle you're dealing with. So keep that in mind. The hypotenuse and adjacent do. So the first thing we're going to do is they're going to give us a triangle, and from that triangle we want to find the six trig functions. So we're going to look at number 1 on page 227 to get started. Alright, so there's my triangle. From that triangle we want to find the six trig functions. And again, every time I ask for the six trig functions, I want you to start by setting it up just like this. So I want to write those six down just like that. Once I have it written down, which two do we want to focus in on finding first? You need to find sine and cosine first. Those are the key to finding the six of them. So, what am I looking for sine? What do I need from the triangle?
Opposite.
So, which side would be the opposite side? 8 squared of 2 would be the opposite side. Which side would be the hypotenuse? 18 would be the hypotenuse. Okay, then I'm dealing with cosine. What's the definition of cosine? Adjacent over hypotenuse. So what is my adjacent side? 14. And we said the hypotenuse was 18. Once I have sine and cosine, I've got everything I need to find the other 4 trig functions. I don't need to look at the triangle anymore. I've got everything I need just from right there. So, Gage, what am I now going to do to get tangent?
It's
What was the trick
to get the tangent,
to get tangent?
opposite over adjacent.
Right, but I don't want you to do it that way. I want you to look at these and tell me what tangent is just by looking at those. What did we just say a few minutes ago? Matthew, help him out. What did we say a minute ago? Kaylee, what did we say a minute ago?
The top of sine over the top of cosine.
The top of sine over the top of cosine gives me tangent. So that's why it's important to find sine and cosine first, because once I have those, then I automatically have tangent. Okay, and then once I have these 3, Reagan, what do I do to get the other 3?
You just flip them.
I just flip them all. So I have 18 over 8 squared of 2, I have 18 over 14, and I have 14 over 8 squared of 2. that's what we're looking to do when they give me a triangle and they want me to find the 6 trig functions. Christian.
So basically, is that saying, the sine of theta? Or,
The sine of theta equals that.
okay.
Okay, so it's saying the sine of a particular angle is this ratio, because that's what a trig function is. It's just a particular ratio, a ratio of 2 sides of a triangle. All right, next type of problem.
That's all we need.
That's all we do.
Oh,
It's just wanting you to identify the 6 trig functions given a triangle.
And,
That's easy.
Yes.
and if they're like X and Z, we just put the
Variables on that.
variables.
Incredibly easy.
All right, next one I want to look at is 13. It says cosine of theta equals 5/9. Cosine of theta equals 5/9. So it gives me one trig function. It wants me to find the other 5. So again, I want you to set it up. Give me all 6 of them at the same time. So I want sine, cosine,
13.
tangent, and then I want cosecant, secant, and cotangent. So they give me cosine is 5/9, so I go ahead and put that in there. But if they give me cosine, what else do I automatically know?
The secant,
I know what secant is. I know secant has to be
9/5.
9/5. What else do I know?
The denominator of tan is 5.
The denominator of what?
Ten.
We do not say tan, Kendrick. We say tangent. You always pronounce the trig function by their full name. So don't say sin, don't say cos, don't say tan, don't say coat, or whatever. I always want the full name whenever you're talking about a trig function. All right, what else do I know?
The numerator of the cotangent.
Carson?
The numerator of cotangent
Is
5.
5. All right, what else do I know?
Ooh,
The denominator of sine is 9.
Denominator of sine is 9. And
the numerator.
the numerator of cosecant is 9. So all I'm missing is one side. Once I find that one side, all I got to do is plug it in. So the question is, what do I need to do to find that missing side? Carson,
Pythagorean's theorem.
outstanding. What is it?
A squared plus b squared equals c squared.
Okay, why am I allowed to use the Pythagorean theorem?
Because it's a right.
Because I'm dealing with the right triangle. You can't use the Pythagorean theorem unless you're dealing with the right triangle. And when I use the Pythagorean theorem, what's the most important side to identify? The hypotenuse, because which side is going to be the hypotenuse? C is. So, if they give me cosine is 5/9, what is my hypotenuse? 9 is my hypotenuse. So that gives me 81 over here on the right. It doesn't matter where I put the 5, so I've got a squared plus 25. And then we solve for a squared. I get a squared equals 56, which means a equals the square root of 56. Now normally when we take the square root, we do plus or minus. Why do I not do that in this case?
You can have a negative.
I can't have a negative side. Matthew, what's your question?
Do you want us to leave it as square root of 56, or do you want us to condense it down to like 2 square roots of, I don't know.
Okay, I am happy with the square root of 56. I am not interested in whether or not you know how to break down a radical. I'm interested in whether or not you can do the trig. So just like on that last problem, what was something we could have done on that last problem that we didn't do? We could have reduced everything. I'm not interested in whether or not you can reduce or whether or not you can break down a radical. I'm interested in whether or not you know the trig. So now that that's the square root of 56, I go in here and put that in everywhere I have a blank. And I have found the remaining 5 trig functions. So that's what you're looking to do on that problem. Questions on that one? Okay, I've got one more problem. Well, 2 more problems, but 1 more type. And you'll need your calculator for the next ones. Yes.
we could be tangent on that.
Oh,
Yes. I will give you 10. So that means c squared will be solved for.
Like 8 times.
It's all in
All right, we're going to look at number 19 next. We're going to look at 19 next. 19 says we want to find the value of x. It says round to the nearest tenth, but we're going to ignore that. We want to round to what? Thousandths place, because we want 3 decimals. So, I need to use my trig to figure out what the missing variable is. Any thoughts on what we're going to do to make that happen?
Use the
Tangent of 11?
Is it 11 times the, Jason,
do sine or cosine.
cosine of 17?
It would be 11 times the sine of 17. But we're going to set it up before we get to that, because you're moving a little bit too fast for me. Okay? So I want to set something up before I can get to 11 times the sine of 17. Kaylin?
Oh, never mind.
What is a trig function?
Ratio.
It's a ratio, so I need to set up a ratio to be able to solve for x. So what am I going to do? Sky?
That's why you're wrong, but do you find the missing angle?
I don't need to find any missing angles.
Oh,
What'd you say? You're a little bit off. You're close, but you're a little off. There you go. Should be sine of 17. Because what does sine of 17 represent? What does sine of 17 represent? What did we say a trig function represents? This right here represents a ratio, so we need to set that equal to another ratio. So what is the sine ratio of my triangle? X over 11. So what we need to do is, whenever I'm dealing with a problem like this, is identify, with the angle they give me, identify the two sides. So what side am I dealing with x? X is the opposite. And what side is 11? It's the hypotenuse. So once I identify the two sides, that then tells me which trig function to use. And we always want, whenever we're doing stuff like this, we always want to use the 3 on the left side. So once I get opposite and hypotenuse, then that should trigger, I need sine. So I need sine of 17, which represents a ratio, and I set that equal to another ratio. And the sine ratio of this is x over 11. Okay? And then we can get to where Kathleen was doing. We move the 11 over. I get 11 sine of 17 equals x, and now we're ready for our calculator. So get your calculator out. We've got, first thing we got to do is make sure we're in the correct mode. Because I'm guessing that a lot of you, your calculators are in the wrong mode. All right, so we want to go to the home screen. Go to the home screen. And then we want to go to settings, which is 5. And then we want to go to document settings, which is 2. So home screen, setting, document settings, and then the second one right here where it says angle, we need to make sure that is in degree mode. So click on it, make sure it's in degree mode. When you do that, go all the way down to the bottom where it says make default, and you want to hit make default to close that screen out. Say it again.
We couldn't get to the home screen.
Are you at the home screen now?
Yes.
Settings, which is 5.
Got it.
Document settings.
Okay.
What one?
Click on angle, make sure it's degrees, and then go down to the bottom and click make default. Now, I noticed when I was clearing your calculators yesterday that a lot of you were using Scratchpad. Do not use Scratchpad. It'll mess up sometimes. You always want to go over here and start a new document. And we're going to add a calculator. Always do a new document. Do not use Scratchpad. It'll mess you up. Sometimes it'll be right, but every now and then it's going to mess up. So do not use Scratchpad. All right, so now all I've got to do is punch it in. So we do 11. Where do I go to get sine?
Trig.
You go to Trig to get sine, and then you select sine, and then we stick 17 inside of it, and press enter, and it gives me that side is 3.216. Now,
the setting we just changed our calculator to, will that mess up any other math we ever try to do in the future?
It only will affect whenever you're dealing with an angle. If you're not dealing with dealing with something with a trig function, if you're not dealing with a trig function, it won't affect anything. So my side is 3.216. What's something I can do really quick to compare 3.216 with to make sure my answer makes sense?
Pythagorean.
That's really quick.
Just put it in the triangle.
Oh, okay, I see.
Can you
We
do,
don't know
how
how
to
to-
sign, 3.2?
What side is 11?
The hypotenuse.
What do we know about the hypotenuse? It has to be the biggest, so we want to make sure our answer is smaller than the hypotenuse.
That's it?
Okay,
We just have to make sure it's small.
Well, and that's something you can do real quick to make sure it's smaller. On the next one we do, we'll have another comparison, and you'll see how that works out too. All right, let's try one more. And the next one I want to do is number 25. So on 25, I'm interested in finding x. I'm interested in finding x. So what is it we want to do to get started?
No, it's
Label the side.
Label the sides. So what side is x?
Opposite.
X is adjacent. How do I know that's adjacent and not the opposite?
not 43.
Touching the angle. If it's touching the angle, it cannot be opposite. So that means this side right here has to be the opposite because it does not touch the angle 43 degrees. So I'm dealing with adjacent and opposite. Once I see the two angles or the two sides I'm dealing with, then I can choose what? I choose tangent. I choose the trig function. So I'm going to choose tangent of 43 degrees. And again, what does tangent of 43 degrees represent? A ratio. Okay, so I need to figure out what that ratio is in this particular triangle. What is it?
7 over 9.
It ends up being 7 over x because the definition of tangent is opposite over adjacent.
So would you divide tangent of 43 by 7?
All right, now this is I'll show you the trick on this one. Whenever your variable is in the denominator, yes, like Kendrick says, I just need to switch these two. So I can put an x here and 7 over tangent of 43 degrees there. I actually did 2 steps
Yeah,
in one right there. What 2 steps did I do?
Dividing by x.
Multiplied by x
Then divide by 10.
and divided by tangent. So I'm just doing 2 steps in one right there. So once we get here, now we're ready to put it in our calculator. So since I'm dealing with a fraction, what's the best way to do that?
Control.
Control divide. In the top, what was it, 7?
7.
And in the bottom, it was tangent of 43. And I press enter, and I get 7.506. 7.506
You got so
is x. Now, this time, I don't have an hypotenuse to compare it to. I've got 7 to compare it to. So, does my answer make sense? And tell me why. Kaylee.
Yeah, it does because it's bigger than 7.
Okay, why does it need to be bigger than 7?
Because it's the hypotenuse. Or no. It doesn't need to be bigger than 7.
Matthew?
That angle that isn't there is going to be bigger than 43, so that bigger angle needs to have a bigger side on it.
So this angle is going to be 47, and the side that goes across from 47 has to be bigger than the side that goes across from 43. So that's why it needs to be slightly bigger than 7. Now, why are these two close?
Because the angles are real close.
Because the angles are real close as well. Okay, so that's something you do real quick to check. Now, I want to prove to you that we are actually dealing with ratios. So what I'm going to do is I'm going to take this x value and stick it back in here and compare this answer with that answer. So to prove that we've got one ratio equal to another ratio. So it was, what was the right side? 7 over x. So I'm going to do control divide. I'm going to put 7. And then instead of putting this just 7.506, I'm going to put this whole answer in here. And I'm going to show you how to do that.
Oh, yeah.
Whenever you want to use the previous answer, you do control and this button right here, and it brings down the answer that was previously there. So I press enter, that gives me that number, and that should match trig tangent of 43 degrees, since I set up one ratio equal to another. So if I do tangent of 43 degrees, it should give me that number right there. We press enter, we get the same number. So that is showing you that all that trig is a ratio. You got one ratio equal to another ratio, and you're solving for the missing part. That's all a trig function is. It's a ratio of two sides of a triangle. Okay? So my 6 trig functions are sine, cosine, tangent, and then the reciprocal functions are cosecant, secant, and cotangent. What are the 2 important ones to fill out first? Sine and cosine. How do I get tangent from sine and cosine?
Top sine over the top cosine.
Yeah, take the numerators and make that, and then how do I get the 3 on the right? Reciprocal. Okay? And then when I'm solving for a variable like these 2 problems, what do I want to do first? Identify the sides, then I identify my trig functions I want to use, and then I set up my ratio and solve. So that's what you're doing when you're solving for x. Alright, so that's a little intro into right triangle trig. Your assignment is over here on the right side. It is page 227, 2 to 26 even.